Have you ever wondered where stars come from? What's their origin story? Picture a universe teeming with swirling galaxies and gleaming stars. Amid this cosmic landscape hide the celestial nurseries, nebulae, where stars are born. These nebulae, shrouded in gas and dust, are the cradles of the dazzling stars we gaze upon. The birth of a star is a fascinating process, a cosmic ballet choreographed by the forces of nature. So, buckle up, space explorers. In this video, we unravel the cosmic mystery of star birth. Before we dive into star formation, we need to understand the birthplaces of stars, nebulae. Nebulae are essentially cosmic nurseries, vast regions of space filled with gas and dust where stars are born. They are like the maternity wards of the universe, cradling infant stars in their gassy arms. Now let's think about the composition of these nebulae. They are mostly made up of hydrogen gas, the most abundant element in the universe. This gas mingles with small quantities of helium, as well as tiny traces of heavier elements like oxygen, carbon, and nitrogen. These elements are the building blocks of stars, and in essence, the building blocks of everything else in the universe, including us. What's more, these nebulae are not just clouds of gas. They also contain dust. This isn't your everyday household dust, though. It's cosmic dust, made up of tiny particles of solid matter. This dust is vital for star formation, as it helps to cool the gas, allowing it to condense and eventually form stars. Now imagine a cloud that's several light years across. That's the typical size of a nebula. To give you some context, a light year is the distance light travels in a year, which is about 6 trillion miles. Even the smallest nebulae are many times larger than our entire solar system. The sheer size of these nebulae is a testament to the grand scale of the universe. But despite their size, nebulae are incredibly diffuse. They are so spread out that if you were to somehow stand inside one, you probably wouldn't even know it. The gas and dust within them are spaced so far apart that they are less dense than the best vacuum we can create on Earth. Nebulae, with their vast expanse, set the stage for the cosmic drama of star formation. They are the places where the raw materials of the universe come together to create new stars, and in doing so, continue the cycle of cosmic life and death. Gravity, the invisible puppeteer, plays a critical role in star formation. It's the cosmic glue that holds the universe together, and it's also the driving force behind the birth of stars. This relentless force is constantly at work, pulling and tugging at every particle of matter in the universe. Imagine a nebula, a vast expanse of gas and dust in space, as an enormous cosmic cloud. It's a hodgepodge of elements, with particles scattered about, moving freely and randomly. But then enters gravity, the great orchestrator of the cosmos. These particles, no matter how small or far apart, feel a gravitational attraction towards each other. Like an unseen hand, gravity pulls these particles together, slowly and steadily. Over time, the random motions of the particles begin to synchronize under the influence of gravity. The particles start to clump together and form denser regions within the nebula. These dense regions, or gravitational pockets, continue to attract more and more matter, growing larger and denser. Now imagine a snowball rolling down a hill, gathering more snow as it descends. This is akin to how these dense regions behave under gravity's influence. The more mass they accumulate, the stronger their gravitational pull becomes, attracting even more particles. It's a runaway process, a cosmic domino effect set into motion by gravity. Eventually, the densest part of the nebula, packed with matter, forms a hot, dense core. This is the birth of a protostar, the first step in the journey of a star's life. It's in this core that the real magic happens, where the conditions become ripe for nuclear fusion, the process that powers a star. But let's not get ahead of ourselves. That's a story for another scene. Gravity, then, is the unseen maestro, conducting the symphony of star formation. It's the force that turns the chaos of a nebula into order, the disorder of particles into the magnificence of a star. Gravity, then, initiates the journey from nebula to star. As nebula particles continue to collapse under gravity, a shining infant star, or protostar, is born. This is a spectacular moment in the life cycle of a star, where the densest part of the nebula begins to collapse under its own gravity. Imagine it like this. The nebula is a vast, billowing cloud of gas and dust. Within this cloud, pockets of gas become denser, creating gravitational wells. These wells pull in more and more matter, and as the mass increases, so too does the gravity. This process of accretion goes on, with material from the nebula continually falling into the gravitational well. As this happens, the core of the well becomes denser and denser, and as a consequence, the pressure and temperature within it start to rise. Eventually, the pressure becomes so great that the hydrogen molecules are squeezed together so tightly they begin to fuse, releasing energy in the process. This is nuclear fusion, the process that powers the sun and all other stars in the universe. At this point, the collapsing nebula has formed a hot, dense core, a protostar. The protostar is enveloped by a cocoon of dust and gas, hiding it from our view. However, as the protostar continues to grow and the temperature in its core continues to rise, it begins to emit radiation. This radiation pushes away the surrounding dust and gas, and eventually the protostar emerges from its cocoon, shining brightly for the first time. So, a protostar is essentially a young star in the making. It's at the very beginning of its stellar life, still growing by accreting material from its surrounding nebula. It's not until the protostar has gathered enough mass and its core temperature is high enough to sustain nuclear fusion of hydrogen into helium that it becomes a true star. With the birth of a protostar, the nebula has successfully given birth to a star. It's an awe-inspiring process, a testament to the incredible forces at work in our universe, and a reminder of our own stellar origins. But the journey doesn't end here. The protostar must grow into a fully fledged star. And this transition, my friends, is a fascinating voyage of cosmic proportions. Picture a protostar, a young celestial object still gathering mass from its parent molecular cloud. It's like a child, growing and developing. But in this case, the child is a burning ball of gas and dust, and its growth is measured in millions of years. As the protostar grows, it continues to heat up. The core of the protostar becomes so hot and dense that hydrogen atoms start to fuse together to form helium. This process, known as nuclear fusion, releases a tremendous amount of energy in the form of light and heat. This is what powers a star and makes it shine brightly in the night sky. But there's a delicate balance to be achieved here. The gravitational force pulling the star's material inward must be perfectly balanced by the radiation pressure pushing outward. Think of it as a tug of war. On one side, you have gravity trying to collapse the star. On the other side, you have the radiation pressure from the nuclear fusion trying to blow the star apart. When these two forces reach an equilibrium, that's when a protostar becomes a main sequence star. This is the state where our sun currently resides, along with about 90% of all the stars in the universe. Main sequence stars can stay in this state for billions of years, steadily burning hydrogen and converting it into helium. It's an incredible transformation, a testament to the power and majesty of the universe. The birth of a star is a cosmic event of epic proportions, a process that takes millions, if not billions, of years. It's a reminder of the grandeur of the cosmos and our small yet significant place within it. Now, the star shines brightly, powered by the nuclear fusion in its core. The protostar has successfully matured into a main sequence star, and its journey continues across the vast expanse of the universe. What happens when the star exhausts its nuclear fuel? The answer to this question is nothing short of celestial drama. It's a cosmic tale of transformation and rebirth that has been playing out for billions of years. The fate of a star after its main sequence phase is determined by its mass. Stars like our sun, which are of medium mass, swell into red giants as they burn through their hydrogen fuel. The outer layers of these giants eventually drift away, leaving behind a dense core known as a white dwarf. This white dwarf cools and dims over billions of years, fading into the background of the cosmos. But let's talk about the heavyweights in the stellar world, the massive stars. These behemoths go out with a bang. When a massive star exhausts its fuel, the pressure at its core decreases and gravity takes over, causing the star to collapse in on itself. The collapse triggers a violent explosion known as a supernova. Supernovae are one of the most spectacular events in the universe, outshining entire galaxies for brief moments in time. The beauty of this explosive end is not just in its spectacle, but in its aftermath. The supernova explosion disperses elements like carbon, nitrogen, oxygen, and iron into space. These elements, which were cooked up in the heart of the star over millions of years, mix with the interstellar medium, creating new nebulae. These nebulae, rich in the building blocks of stars and planets, are the cradles of new stellar generations. So, the cycle continues. Stars are born, they live, and they die. And in their death, they sow the seeds for new stars, planets, and perhaps even life. The universe is a grand cosmic recycling plant, where matter is never wasted but continually transformed. The death of a star, thus, sets the stage for the birth of new stars. From the ashes of the old, the new arise. This is the rhythm of the cosmos, a dance of creation and destruction that has been unfolding since the dawn of time. The universe, with its cosmic ballet of star birth and death, never ceases to amaze. We've journeyed through the cosmos today, delving into the intriguing mystery of nebulae, the celestial cradles where stars are born. These vast, vibrant clouds of dust and gas are more than just a spectacle for our telescopes. They are the incubators of the universe, the starting point of a star's life cycle. We've learned that gravity plays the pivotal role in this process, pulling together these particles of dust and gas to form a dense, hot core, the birth of a protostar. This protostar, still hidden within the nebula, continues to grow, fueled by the matter falling into it. It's a tumultuous time in a star's life, filled with intense heat and pressure. But through this chaos, a star is formed. The protostar morphs into a main sequence star, initiating the process of nuclear fusion. It's at this point that a star, as we commonly recognize it, is truly born. This cycle of star birth and death is a reminder of the dynamic nature of our universe. Each star, from the ones that twinkle in our night sky to those that exist in galaxies far beyond our own, has undergone this incredible journey. From a mere particle in a nebula to a glowing beacon of light, each star has a story to tell. But nebulae and star formation aren't just about the birth of stars. They're a testament to the universe's ability to recycle and renew itself. When a star dies, it doesn't just fade away. It returns its elements back to the universe, contributing to the creation of new stars, new planets, and perhaps new life. The beauty and significance of this process extend beyond the realm of astronomy. They touch upon the philosophical, reminding us of our own mortality and the cyclical nature of life. We are, after all, made of stardust, born from the remnants of stars that exploded billions of years ago. So the next time you gaze at the stars, remember the incredible journey they've taken from nebulae to the night sky. Each twinkle is a testament to the universe's grand cycle of birth, death, and rebirth. Each star, a reminder of our connection to this vast, beautiful cosmos we call home.